This is Group U2 presenting Lab 4.
In the first question, we were asked to find the annual loss in consumer surplus in a market where the price increased from $1.25 to $1.75. Uh, Using the linear demand curve with as per the equation, we found that the consumer surplus loss would be 6.9 million, while using the constant elasticity demand curve as per the equation, we found that the annual loss in consumer surplus would be 7.03 million.
Okay, so for the next problem, concerning the gross social benefits of building a swimming pool, we used the Excel sheet provided, which ran a regression on the table that was given, with the variable visits as benefits and the y value for the regression, and the variables fee, income, and population as the x values. And after running the regression, the demand curve can be found by setting visits as quantity and fee as price, and then putting the rest of the numbers into the coefficients given by the regression and just adding those up. So the demand schedule will be quantity or number of visits is equal to 183,315 minus 14,600 times price or fee. If you plug 0 in for the p-value, you get 183,315 visits if the fee is $0, and so that number of visits would be the gross benefit.
So for part B of this question, we are asked to calculate the gross benefits if the emission was set to $1 for the public swimming pool, and the town had a marginal excess tax burden of 0.25. So to do this, we first had to calculate the total fee revenue before we calculated the gross benefits. And to do that, we used the linear equation we got in part A, plugged in $1 into the equation to get the quantity of people that would come. That came out to 168,715. Then to get the total revenue, we just multiplied that by the price of the ticket, so price times quantity, and so that came out to $168,715. Finally, to get the marginal excess tax burden, we did 1 minus the tax burden of 0.25, which would be 0.75, and multiply that ratio by the revenue, which is $168,000. And then the end gross benefits that you would get would be $126,536.